Article 527 in the National Electrical Code, that's NEC, addresses temporary electrical power. When powering portable structures, safety and compliance are paramount. Several options exist to provide power safely and in accordance with the NEC. Firstly, consider an overhead service entrance. This involves installing a weatherproof service entrance box on the exterior of each building equipped with a cord cap and inlet. Run an overhead service drop cable from the main distribution panel to each service entrance box. Then connect each portable building to its corresponding service entrance box using a locking cord cap. Secondly, a weatherproof cord cap and receptacle arrangement is another possibility. In this method, a weatherproof box is installed on the exterior of each building, featuring a short, approximately 2-foot cord with a cord cap. Then run a suitable cable, such as UF cable, from the existing outdoor receptacle to the weatherproof box. The portable building can then be plugged into the cord cap on the box. Thirdly, consider installing a power distribution panel inside each portable building. This entails running a feeder cable from the main service panel to the distribution panel within each structure. Individual electrical devices, like lights and receptacles, are then connected to this distribution panel. Regardless of the chosen method, several features are highly recommended. Firstly, prioritize locking cord caps. Ensure that both the cord cap on the building and the inlet or receptacle are of the locking type. This crucial detail prevents accidental disconnections, especially in environments with high foot traffic or movement. Secondly, utilize weatherproof boxes and cable. Employ weatherproof enclosures and cables to safeguard electrical components from exposure to the elements such as rain, snow, and sun. Thirdly, implement ground fault circuit interrupter, that's GFCI, protection. Install a GFCI device, either within the service entrance box or the power distribution panel, to provide protection against electrical shock. GFCI devices quickly interrupt the circuit when a ground fault is detected, significantly reducing the risk of injury. Fourthly, ensure adequate circuitry. Provide sufficient amperage and circuit capacity to handle the electrical load of all devices within the portable building. This prevents overloading circuits and potential hazards. Additional considerations are important. Obtain all necessary permits from the local building and electrical authorities before commencing any electrical work. Engage a qualified electrician to perform the installation and conduct thorough inspections of the system. Establish a routine schedule for maintaining and inspecting the electrical system. This ensures ongoing safety and proper operation. Some additional, more granular considerations are discussed below. The most important consideration is safety. All electrical work should conform to NEC standards and local codes. The improper wiring of the original setup is a significant safety hazard. The backfeeding of power using male cord caps on both ends of a UF cable creates a dangerous situation because the energized male pins are exposed when the cord is disconnected from the receptacle. This presents a shock hazard to anyone who comes into contact with the exposed pins. This setup violates electrical safety standards and should be discontinued immediately. Moving forward, the use of flexible cords and cables should be appropriate for the environment. Given that these are temporary installations at a fairground, the cords and cables will be subjected to mechanical wear and tear. Cords should be selected with consideration for exposure to sunlight, moisture, and physical damage. Where cords pass through openings, they should be protected from abrasion. Strain relief should be provided at cord connections to prevent stress on terminals. Overcurrent protection needs to be appropriate. Each circuit powering a light or receptacle should be protected by a circuit breaker or fuse of the correct amperage. The overcurrent protection device should be sized according to the ampacity of the conductors. It should comply with NEC requirements for conductor protection. The size of the conductors, that is the wires, feeding each portable structure must be adequately sized to handle the load and voltage drop. The conductors should be sized according to NEC Table 310.15b16. Voltage drop should be limited to 3% for the feeder and branch circuits combined. All metal enclosures and non-current carrying metal parts of the electrical equipment must be properly grounded. This grounding should comply with NEC Article 250. A grounding electrode system may be required if the portable structure is considered a separately derived system. Each receptacle should be of the grounding type, and each should be properly grounded. Grounding provides a low impedance path for fault current to return to the source, which helps to trip the overcurrent protection device in the event of a ground fault. The use of a GFCI is strongly recommended for all receptacles that are accessible to the public or located in damp or wet locations. GFCIs protect people from electric shock by detecting ground faults and interrupting the circuit quickly. As mentioned earlier, locking type connectors should be used for all cord and plug connections to prevent accidental disconnection. This is especially important in areas where there is movement of people or equipment. Where applicable, the electrical equipment should be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, that is UL. Listing and labeling indicates that the equipment has been tested and meets safety standards. All electrical work should be performed by qualified personnel who are familiar with the NEC and local electrical codes. If the structures are truly portable and move frequently, then a flexible wiring method is more practical. However, if they remain in one location for extended periods, then a more permanent wiring method may be appropriate. A suitable option is to install a small panel board in each structure fed by an appropriately sized cord with a plug. The cord would plug into a receptacle fed from a breaker in a main panel. The receptacle should be protected by a GFCI breaker. Another potential solution involves the spider box. A spider box is a portable power distribution center that can be used to provide temporary power to multiple loads. The spider box would be fed from a generator or main panel, and then branch circuits would be run to each portable structure. When using this method, ensure that the spider box is properly grounded and protected from the weather. Always consult with the local electrical inspector to determine the specific requirements for temporary power installations in the jurisdiction. Requirements can vary depending on local amendments to the NEC. The existing practice of backfeeding power with male cord caps is extremely dangerous and violates the NEC. It should be discontinued immediately. The best way to provide power to the portable buildings is to install a 2-foot cord with a cord cap coming out of a weatherproof box on the outside of the building. Then the structures can simply be unplugged to move them. This is a safe and compliant solution as long as the cord and plug are rated for the appropriate amperage and voltage, and as long as the receptacle that it plugs into is GFCI protected. Remember that it's important to follow all applicable codes and regulations. If unsure, it's always best to consult with a qualified electrician. Here are some additional points to consider when dealing with portable structures. It is important to define what constitutes a portable structure. In the context of the NEC, a portable structure is one that is designed to be easily moved from one location to another. This contrasts with a permanent structure that is intended to be fixed in place. The NEC provides specific guidance on wiring methods for portable structures. The code emphasizes the use of flexible wiring methods to accommodate the movement of the structure. Some examples of flexible wiring methods include flexible metal conduit, liquid-tight flexible metal conduit, and cord and plug connections. Permanent wiring methods, such as rigid conduit or non-metallic sheath cable, are generally not suitable for portable structures because they do not allow for easy movement. The location of the portable structure is another important consideration. If the structure is located in a wet or damp location, then all electrical equipment must be suitable for wet locations. This includes weatherproof enclosures, non-corrosive materials, and GFCI protection. The NEC also has specific requirements for the grounding and bonding of portable structures. These requirements are designed to ensure that the structure is properly grounded and bonded to prevent electrical shock hazards. In general, the grounding and bonding requirements for portable structures are similar to those for permanent structures. It's important to properly size conductors for the load. The conductors that supply power to the portable structure must be sized to carry the load. The size of the conductors will depend on the amperage of the load and the distance from the power source. The NEC provides tables and guidelines for determining the appropriate conductor size. Finally, remember to inspect and test the electrical system regularly. Once the electrical system is installed, it's important to inspect and test it regularly to ensure that it is functioning properly. Regular inspections can help to identify potential hazards, such as loose connections or damaged wiring. Testing, such as ground fault testing, can verify that the system is providing adequate protection against electrical shock. Remember that the NEC is a complex document, and it can be difficult to understand all of the requirements. If there are any questions or concerns, it's always best to consult with a qualified electrician or electrical inspector. Electrical safety at fairgrounds is critically important. These locations often have a high volume of people, temporary setups, and exposure to the elements. Here's a breakdown of key considerations and best practices. Firstly, implement thorough inspections. Regular inspections of all electrical installations, both temporary and permanent, are essential. Look for damaged cords, overloaded circuits, and improper grounding. Document all inspections and promptly address any identified hazards. Secondly, manage temporary wiring properly. Temporary wiring is common at fairgrounds, but it must be installed and maintained correctly. Use only approved cords and cables suitable for outdoor use. Protect cords from physical damage and ensure they are not creating tripping hazards. Never overload temporary circuits. Thirdly, ground fault circuit interrupters, that is GFCI protection, is vital. GFCI protection should be used for all receptacles located outdoors or in damp locations. GFCIs can prevent electrical shocks by quickly shutting off power when a ground fault is detected. Test GFCIs regularly to ensure they are functioning properly. Fourthly, ensure proper grounding. All electrical equipment and metal structures must be properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock. Check grounding connections regularly to ensure they are secure and corrosion-free. Fifthly, maintain adequate clearances. Maintain safe clearances around electrical equipment to prevent accidental contact. Keep vegetation and other obstructions away from electrical panels and transformers. Sixthly, control access to electrical equipment. Restrict access to electrical equipment to authorized personnel only. Lock electrical panels and enclosures to prevent tampering. Seventhly, train personnel to identify and respond to electrical hazards. Provide training to fairground staff and vendors on electrical safety. Teach them how to identify electrical hazards such as frayed cords or sparking equipment, and how to respond safely. Eighthly, manage overloads carefully. Avoid overloading electrical circuits. Use appropriately sized extension cords and power strips. Be aware of the total amperage draw of all equipment connected to a circuit. Ninthly, be aware of weather conditions. Weather can significantly impact electrical safety. Take extra precautions during wet or stormy weather. Cover electrical equipment to protect it from rain and moisture. Tenthly, comply with the National Electrical Code. All electrical installations must comply with the NEC and local electrical codes. Obtain necessary permits and inspections for temporary electrical setups. In addition to these general considerations, there are also some specific hazards to be aware of at fairgrounds. These include overhead power lines, underground utilities, and portable generators. Maintain safe distances from overhead power lines. Call before you dig to locate underground utilities. Use portable generators safely and in well-ventilated areas. Remember, electrical safety is everyone's responsibility. By following these guidelines, one can help to create a safer environment. For the specific setup described, where there are 4 6-foot by 6-foot buildings on skids with 1 light and 1 receptacle each, and they are moved around the fairgrounds as needed, several NEC articles are especially relevant. As previously mentioned, Article 527 covers temporary electrical power. This article provides requirements for the installation and use of temporary electrical power systems, including wiring methods, grounding, and overcurrent protection. Article 590 also addresses temporary installations. This article provides additional requirements for temporary electrical installations such as those used for construction, carnivals, and fairs. Article 305 covers temporary wiring. This article provides requirements for temporary wiring methods, including the use of flexible cords and cables. Article 400 covers flexible cords and cables. This article provides requirements for the construction, installation, and use of flexible cords and cables. Article 250 covers grounding and bonding. This article provides requirements for grounding and bonding electrical systems to ensure safety. In a specific scenario, where buildings are moved frequently, cord and plug connections offer the most flexibility. However, these connections must be made safely and in accordance with the NEC. The suggestion to install a 2-foot cord with a cord cap coming out of a weatherproof box on the outside of the building is a good starting point, provided that the receptacle is GFCI protected. In addition to the items already discussed, here is a list of additional NEC requirements that may apply to portable structures. Firstly, disconnects. Each portable structure must have a disconnecting means that is capable of disconnecting all ungrounded conductors. The disconnecting means must be readily accessible and located within sight of the structure. Secondly, overcurrent protection. Each portable structure must be protected by overcurrent devices, such as circuit breakers or fuses. The overcurrent devices must be sized to protect the conductors and equipment. Thirdly, wiring methods. The wiring methods used in portable structures must be suitable for the environment and the type of occupancy. Flexible wiring methods, such as flexible metal conduit or liquid-tight flexible metal conduit, are often used to allow for movement of the structure. Fourthly, grounding. Each portable structure must be properly grounded to protect against electrical shock hazards. The grounding system must comply with Article 250 of the NEC. Fifthly, receptacles. All receptacles installed in portable structures must be of the grounding type and must be protected by GFCIs if they are located in wet or damp locations. Sixthly, lighting. The lighting in portable structures must comply with Article 410 of the NEC. The lighting fixtures must be suitable for the environment and must be properly installed. Seventhly, appliances. Any appliances installed in portable structures must comply with Article 422 of the NEC. The appliances must be properly grounded and must be protected by overcurrent devices. Eighthly, heating and cooling equipment. Any heating and cooling equipment installed in portable structures must comply with Article 440 of the NEC. The equipment must be properly grounded and must be protected by overcurrent devices. When using cord and plug connections, follow these best practices. Select cords and plugs that are rated for the appropriate amperage and voltage. Use cords and plugs that are listed by a recognized testing laboratory such as UL. Inspect cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Ensure that cords and plugs are properly connected. Do not overload cords or plugs. Protect cords and plugs from physical damage. Do not run cords through doorways or windows where they can be pinched or damaged. Use strain relief devices to prevent stress on cord connections. Use cord reels or other methods to keep cords organized and out of the way. Avoid using extension cords whenever possible. If an extension cord is necessary, use a heavy-duty extension cord that is rated for the amperage of the load. Do not use multiple extension cords connected together. All electrical work should be performed by a qualified electrician who is familiar with the NEC.